Hello, everyone. So today we'll talk about differentiation. I'm sure you have the idea of differentiation through your previous classes, but we'll just take a look at some standard forms or some complicated examples just to drive through a point. So differentiation, you know that it is there's a function y is equal to some function, let's say x or whatever. What we do is we write dy by dx. Now, the meaning of this is that what is what is the change in y if I change x slightly, right? And this is the science of change. It has huge applications. Huge means huge application in every field, finance or engineering or computer or any you talk about anything. And then this comes from something called, if you remember, we evaluated limit dy by dx is equal to fx plus h minus fx, right, by h. And when h was so small and whatever you got was dy by dx, that's called instantaneous change, right, for instant change in the variable. So that's what it is. It is the science of change, changing a quantity and see what happens to the other quantity and changing by a very small amount. With this, you can evaluate cos x, sin x. In fact, you can evaluate anything for that matter. This is called first principle. So I'm not getting into it. Let's take this for example. So if the intent is to get the derivative of 10x with respect to x, please remember, right? I can differentiate it for all I care with respect to z, which will be 0. So what we are saying is if I want to evaluate it, I can write it as sin x by cos x. Why am I doing it? We'll just come get to know in a minute. And then I can write it as sin x into cos x minus 1. And I can write it like this. Now, there are two functions now. And there's something called product rule. Yeah, it is product rule. But it says that you differentiate one function and keep the other one as it is. And then the other function, keep the other one as it is. You can choose anything as first function, right? So I'm choosing this as first function because I want negative to be in my second term. So when I choose this as first function, I write cos x to the minus 1 and derivative of this, which is cos x, plus this remains as it is, and I need to write the derivative of this. Now this is sin x, and now any function of the form x to the n has differentiation nx n minus 1, right? Just remember this. So when I differentiate this, what I get is minus 1 cos x minus 1 is minus 2. If inside there is a variable to with, I mean, this x you are still differentiating, you will have to write the derivative of this as well. So derivative of the cos x will be equal to minus sin x, which is standard. Now, if you evaluate this, these two will cancel out. I'll get 1 minus minus plus sin x sin square x by cos square x. So this will be 1 plus 10 square x, which is nothing but sec square x, right? So I just wanted to drive home these 2 points. That one, the derivative of power of a variable, you get the variable down and subtract 1 from the power, and 2, anything which is inside which is differentiable, you multiply the derivative of the same. These are standard ones, but I will strongly urge you to derive them once, just once, so that you can, whenever you use them as a standard function, you're not really taken aback that what's happening. Then these are some inverse function, right? Now the way with the inverse function is, suppose I want to, again, I'll take the same example. I want a derivative of tan inverse x with respect to x, of course, right? And this is the function. I can write x is equal to 10y, right? Now, if I differentiate it, remember I have to differentiate with respect to x. So I can differentiate both sides with respect to x. And what do I get? I get differentiation of x with respect to x is 1. Why 1? X to the 1. Now this will be 1 x 1 minus 1, which is x to the 0, which is 1. So I'll get 1. And this side, we just did this. And the derivative of y. Remember, y, I mean, you can have a differentiation of y with respect to x, which is nothing but dy by dx, right? So dy by dx here is equal to 1 by sec square y. But this is y. I need to have x here. Where is the original thing? Here. X is 10y. We can convert it easily, that we can write this is 1 plus 10 squared y, which is nothing but 1 upon 1 plus x squared. So with all the inverse function, please make sure that you reverse them, and then you get your desired derivative and get it back to the form it had to be. Let's see the next thing. Again, these are standard. A to the x is ax. This is natural log, right? Please remember this is natural log e base. This is again very, very useful. D by dx of ex is ex. Please derive them. And this is log base a, right? So just remember d by dx of ln x. I interchangeably write ln as log, and everyone understands it unless it is specified is 1 by x. But d by dx of this is natural log and this is log a base x, right, is 1 by natural logarithm a into x, and these two are different. Okay, now let's come to the rules. I don't encourage anyone to remember these rules. I encourage people to do so many questions that these are this is just a muscle memory. I was talking about two functions, first function into second, second function is to first. You can choose any function as first and second you desire. I can have three functions. I can group these. I can take this as first function and this as second. And then again, do the same stuff with this. I mean, this chain can go on and on and on. Then there's something called the division rule. Let me just see if it can come here. Division rule is all about u by v. I don't do that. I don't encourage it. You should write d by dx of u and v to the minus 1, and then come here, right? Let's attempt some question which will illustrate whatever we have learned till now. For example, I have this thing which is done here. I've done here for your reference so that you could see later. But I'm not going to do it this way. What I'll do is I'll write x cube plus 2 to the x into ex, correct? Minus. Do you understand? I've taken it upstairs. Now I will apply the product rule or whatever you say. All right. Let's take this as first function because there'll be negative. So I want negative to be in the second term. It doesn't matter. So when I differentiate it, it will be 3x squared 2 to the x. The differentiation is 2 to the x ln 2. So I'm writing, okay, let me write ln 2. I write log 2. That's okay. All right. And the plus sign and e to the minus x remains as it is. Plus differentiation of e to the x is e to the x, but it is e to the minus x. So you'll write minus 1 e to the minus x. And then you write the original thing, which was x cubed plus 2 to the x. All right, now you can take this downstairs. And how do you take it downstairs? You can take it downstairs. You can take it downstairs. One sec, let me check. This is properly being recorded. Yeah, fine, fair enough. Yeah, you can take it downstairs means I'll take it away from here. I'll write e to the x. I'll take it away from here. I'll write e to the x. That's algebra, basic algebra, and you'll get the same answer. This common, this negative will come in between. Let's look at one more example here, which is sin x to the cos x and to the power cos x. So how do you do that? Whenever there is something in power, just remember to take logarithms on both sides, right? Natural log. So what we are saying is that let y is equal to sin x to the cos x. And if you say log y is equal to log this particular thing comes here. I don't want to write it, but I'm sure you can say that log a to the x is x log a. So it'll be cos x log sin x. Now let's differentiate. Okay, 1 by y into dy by dx, right? And there'll be some differentiation of this, which will be cos x plus 1 by x log x minus sin x, right? Whatever this thing will be, you multiply y with this and then substitute the original value. You will get the answer here. This was simple. And the point is that whenever there is something in the power, which is a function itself, please take log. Uh, Sometimes there are parametric forms. So two variables are given. For example, this is a question which says x is equal to a cos theta and y is equal to a sin theta. Remember, I am asked to evaluate dy by dx. What do I get? I get dx by d theta, which is minus a sin theta. Okay. And I get dy by d theta is nothing but a cos theta. But I don't want dx by d theta by dy by d theta. But then I know for sure is dy by dx can be written as dy by d theta. Either you divide or multiply, it doesn't matter, into d theta by dx. Substitute the values, right? Remember, I have taken the reciprocal in multiplication. You want to divide, you can divide it straightforward and you'll get your answer. Where is it? Here. Okay. Let's look at one more example, which is, okay, which says that, look, you differentiate a function with respect to another function. That means small change in another function will impact the one function, the first function. How? So it says differentiate sine squared x with respect to e to the cos x. My suggestion would be give these variables some names, u and v. And remember, I need to get du by dv, right? But here I'll get du by dx, and here I'll get dv by dx. And the trick, you already know the trick, that du by dv can be written as du by dx. Divide or multiply, it's up to you. If you multiply, take the reciprocal into dx by dv, substitute the value, and you will get the answer. That's the point that I wanted to drive home. Now, there will be instances where you will be asked to differentiate a determinant. So that's fairly simple. Differentiate first row, leave everything as it is. Second row, leave everything as it is. Third row, and leave everything as it is. For example, in this example, sec theta, tan square theta, and 1. Sec theta is 0. Remember, we have to differentiate with respect to, right now we are differentiating, we have to differentiate with respect to theta, f dash theta. But the function is fx. So if I differentiate it with respect to x, sec theta will be 0, this will be 0, and this will be a constant function 0. These are constant with respect to x. You can't, I mean, these are not constant, but with respect to x, if you change x, nothing will happen to theta. Here you get this one. The rest is as it is. Then first is as it is. If you differentiate this, you get 0, you get sec square x, you get 1, 0 sec square x 1. Then in the third case, you this, this as it is, this as it is, and the last thing, which is 1 minus 10x 10 theta, it'll be sec square x, it'll be 0, it'll be 0. And when you add these, you get f dash theta. So that's your answer. One more substitution which is important, that there are a lot of times that you will get, for suppose somebody says you have to differentiate a squared minus x squared, right? Uh, or x squared plus a squared, right? Or a squared minus x squared. Substitution helps a lot, right? So whenever you have a squared minus x squared, substitute x is equal to a sine theta. This will use lot in integration, right? If this is a plus, it is a tan theta. And if the a is in front and the x square is behind, then you do a sec theta. We'll do an example for that. Then please remember this, and remember these. We'll use them in integration or not. I just wanted to, make you uh, make your memory a little, you could recall whenever you wanted. For example, a function is given which is cot inverse 1 plus x squared. This is in root, and then this is plus 1 by x. Now this will be absolutely nightmarish to, first equate it to y and then get differentiated with respect to. You can do that, nobody stops you, but then under root and all this. Instead, if you substitute x is equal to tan theta, the moment you do that, you get sec theta plus 1, right? And then you write sec theta is 1 by cos theta, and then simplify it. It'll be cot inverse. I mean, I hope you understand what I'm trying to say. That this particular thing would be 1 by cos theta plus 1 con sine theta by cos theta, right? And then this will be this factor. And then I'll get theta by 2, right? Tan inverse x, y is equal to. Then you calculate it, and then you get your answer. That's all about it, I think. And we will just go back and see what we've done. It's always better to take a revision route and see what we've done. We talked about the first principle, and we said we can do this all with first principle. I have encouraged you to please, it takes 1.5 hour to do everything, but these are required. Then I talked about some standard derivatives which would be used very frequently. Then I talked about product rule, quotient rule, chain rule. I don't know what rules, I don't really care. But with a little bit of common sense and cleverness, you can juggle around with the numbers or the variables and get it. So this is about differentiation, hardcore differentiation. We'll have to deal a lot with the application of the same. So thank you for being there. I'll see you next time.